Right, well, that's the corrosion neutralised and sanded down, so we're back down to bare copper now, all across this board at the bottom. I'm just washing it with isopropyl alcohol at the minute. That's why it's wet, and the same on the back. We've sanded all that down, got rid of all the corrosion. I'm just washing that side as well. That's why it's got this shine on it. It's the isopropyl that's just currently drying. Right, so we've got the recently refurbished rectifier board on the transformer block back into the cabinet, and the next job we've got to do is sort these damn connectors out. This one here, it's a bit burnt, so we're going to put a new housing on, and well, we're going to cut all those wires and put brand new trifurcon pins on every single one of those. So we'll do that now. Well, here's one thing we can do. Here's the old scabby, definitely non-working rectifier board, and here's the one I've just recently restored. Well, it's new connectors, new caps, new pot for the high voltage. It's all been cleaned up and tested. Right, we're all done apart from the last wire. Oh, these sleeves here are just some heat shrink because the insulation, no, you can't really see it very well. The insulation's got a little bit of damage on it where someone's hit it with a soldering iron. It's not come through to bare wire. Yeah, there's a bit there, look. It's not come through to bare wire, but this is just to protect the wire. So we'll just heat shrink that over. Right, so the last wire is this one, which goes into a 12-way connector bodge that someone's done. It's too short now to reach directly, so we're just going to snip a bit of proper wire, we'll join it, solder it and heat shrink it and then crimp it on. Right, I've just unscrewed the cabinet wiring harness now, which comes from the main switch. Well, it's got other things on here, but we've got the mains going in. This one looks a little brown, nothing terrible, but we're going to replace this and put some new pins on as well. So that just gives me a bit of room to work while I'm crimping it. New connectors are there, and let's get on with that one. Right, now that that connector has been repinned, we're almost ready to power up, but we need to first of all do some earth testing. So we've stuck a crock clip on the earth pin in the plug, multimeter resistance setting, and a crock clip on this side. So let's give it a test. Back box. It helps that it doesn't fall off. Right, back box is clamped. Open circuit, so the earth to the back box is not okay. Side rail. 3.7 ohms. Okay, that's a bit high. Should be lower than that. Need to find out why. Other side rail. Open circuits. That's not connected. That's not good. So lockdown bar mounting. Okay, 0.5, 0.4. That's fine. So that's good. That's the only one that's good so far. What else have we got? So this is the main braid in here. Actually, that'll be fairly low. 0.4. It's probably about a base reading. Wire's getting tangled up. Need to check. This isn't connected yet to the earth. There's an earth lead here. Can't do this with one hand. Well, that's fine as well, so that's going to go on to this here, which I haven't done yet, which will also earth the transformer. Legs, that's what else we need to check. Can't really. This is annoying. 0.5 on that one. I think I'll change probe. That's not good. Fairly a bit high on that one. And can't really see on the camera. That's open circuit. And well, I know that one is because it's not connected. So we've got a few earth issues to fix first. Right, I've repaired all the earth now. So back box connection. 0.1 of an ohm. The legs are fine, let's do a leg. 0.7. The only thing that's still a problem really is this side rail. And what that is, that bolt there, that's the earth coming through there from that strap. Now if I touch on this metal strap here, we've got 0. So it's definitely a bolt. Let's take this bolt out and clean it up and put it back in again, that might fix it. Right, as I don't have replacements in a minute, I've just attacked the washer, the nut and the bolt with a file, got off all the corrosion that was underneath it, made sure these are all good surfaces. I've put a little bit of sandpaper on the rail here, and I think once we reconnect this now it'll be absolutely fine. Right, let's recheck these rails. So 0.4. And 0.3. So they're both now working fine. So we've increased the safety of this cab tenfold already. Now in nearly every pinball machine they have this a service socket. Now it's actually no use in the UK because it's always like an American socket or something. I think that's an American socket. And I don't like them because basically it means you've got permanently live power in the cab when it's switched off, as these come in directly from the mains. So you've got a run of wire all the way down the cab that's live. Also, I just sort of pulled on these wires here, and one of them just fell out. Let's see if I can do it. So yeah, that's not good. So I'm just fixing this messy wiring. Oops, get this off. Just fixing this messy mains wiring here. So I was just identifying which of the two is for the accessory socket, and I'm just basically going to cut that and not connect it, and I'll just connect up that's the mains feed to the switch, that's the mains one to the socket. So I'm just going to isolate that socket, and that'll make it a lot safer as well. Right, we've got the test clips hooked up and the meter out so I can see it. And this is the bit I absolutely hate. It's the first power up to see if it smokes or not, and I hate it when they smoke. So fingers crossed. I've done everything I can. Rectifier board's been rebuilt, mains lead's been sorted out. I've tested it and tested it and tested it. I can't think of anything else to test, so it's fingers crossed time. Right, I'm remotely powering it up like a wimp, and we're ready. Oh, I can see the meter's reading 6.5, that's on the 5.4 line with no load. That's actually very quiet. Very little transformer hum. Okay, that's kind of working. Let's switch off and try some more test points. So the 43 volt DC output is not actually outputting anything, so it looks like we've got a bit of an issue we need to trace out. I've hooked onto the transformer and we're getting 55 volts AC coming out and going to the rectifier board, but nothing on the output of the 43 volt DC out. So potentially the fuse is blown. I need to check that first, which means there might be a short. So potentially that varistor or one of these bridge rectifiers. Let's check it out. Well, the fuse tests good, so it's not the fuse, so potentially that rectifier isn't working, or there's a wiring issue. Right, these are the power inputs to the power drive board here, or at least this one is. And the contacts look a little crusty, so I think it's time to repin this. This is obviously important to get good contact here, good voltages going in, so definitely want to repin these. Probably repin most of the connectors to be honest, but these are critical ones, so let's do these first. Right, well we're half done on this plug and you should be able to see the difference between the shiny new connectors and the dull corroded old ones. There you go, that's both connectors all done now with new shiny pins. So even if there wasn't anything wrong with them, which well I'm sure there was, they were quite glossy pins, I don't have to worry about this for several years. A bit dark in here, but yeah, as we've put on new connectors on the board as well and repin these, that'll last another 20-30 years before it needs any more attention, hopefully. Well, that's it now, there's no stopping me. I'm going to repin every connector. Some of these pins are pretty terrible, so I think it's definitely worth doing. Let's see if we can get in close on this one. This one I've just taken out. You can see it's really horrible. They're all pretty much like that lot. There's one I've just done. These ones are all green or black. So yeah, I'm going to do them all, and then they should all be reliable.